Hi everyone, this video is going to go over parts of the Lesson 8 notes, and really it's going to be kind of a big review of what we have done in Lessons 1, 3, and 4. So in Lesson 1, we talked about using f prime to identify critical points, intervals of increasing, and intervals of decreasing. In Lesson 3, we talked about using the first derivative test to identify the location of relative extrema, so relative mins and maxes. And then in Lesson 4, we used the second derivative to identify points of inflection and intervals where the function is concave up and concave down. So we are going to take all of those ideas and really put them together into one. Now, here on page 50 in your packet, there's pretty much just everything that we know about using the first derivative to identify critical points and intervals of increasing and decreasing. So I'm not going to talk through all of it. This is just one place where all the notes are. Page 51 then has all the information about points of inflection and identifying intervals of concave up and concave down. So again, it's really this big overview of what we did in the first few lessons of this unit. And so going through that and being able to do this problem that we're going to do in the video is really what's going to help you make sure you are prepared for this mini summative that we are taking next week. So if you will please join me on page 52, this is the problem that we are going to go through to help make sure you are ready for your summative. The figure below shows the graph of f prime, so it's going to be important to notice that that's the graph we are looking at. It's not the graph of the original function. We have the derivative on the closed interval from -1 to 5. We want to find all the information and make sure we justify all of our answers. That's going to be super, super important. The first thing we are asked to find are the critical points. So before you try and figure anything out, think through anything, or try and write an answer, excuse me, you want to think through what it is. So critical points, we know, are when f prime of x, or the first derivative, is equal to 0 or does not exist. So we want to think about what that means. The first derivative is equal to 0, and this is the graph of the first derivative. That means I'm going to be looking at the x-intercepts. So I would say f of x has critical points at x equals 1 and x equals 4 because f prime of x is equal to 0 at these values. And remember, you have to have that justification. The next thing we're asked to identify is where the function is increasing. So again, think about what that actually means. For a function to be increasing, it means that the first derivative, or the slope, is positive. It's greater than or equal to 0. Well, f prime of x, this is the graph of f prime of x, which means I'm going to be looking for where is this above the x-axis. So on this interval here, f prime of x is positive. That means f of x is increasing on the interval from 4 to 5 because, ooh, that should be a bracket there, not a parenthesis. Sorry about that. Because f prime of x is greater than or equal to 0 on this interval. We know a function is decreasing when f prime of x is less than or equal to 0. Since this is the graph of f prime of x, we're looking at what's below the x-axis. In this case, that is this entire section from -1 all the way to +4. So f of x is decreasing on the interval -1 to 4 because f prime of x is less than or equal to 0 on this interval. Now we have to think about the relative maximum and the relative minimum. In order to do that, we have to think about what that actually means, right? So I'm just going to below there kind of sketch some stuff out here. A function has a relative maximum if f prime changes from positive to negative, right? If the function changes from increasing to decreasing, then we know that the function has a relative maximum. If f prime changes from negative to positive, in other words, the function changes from decreasing to increasing, then the function has a relative minimum. Well, then let's take a look at where the f prime crosses the x-axis. Sorry about that. We have the critical points are at 1 and 4. So we just really need to know what those critical points are. Are they a min, are they a max, or are they none of them? Well, at x equals 1, f prime of x hits the x-axis and then goes back down, which means f prime of x is negative on both sides of that critical value. Since f prime does not change any signs, right, it stays negative, then x equals 1 is not a min or a max for this function. So for that one, it doesn't matter. At x equals 4, however, f prime of x changes from negative to positive. So f prime was negative, the function was decreasing, and then it changed to positive, the function increased, started to increase. That means we have a relative minimum there. So f of x has a relative minimum at x equals 4 because f prime of x changes from negative to positive at this value. For the relative maximums, we would say there are none on this interval. And the reason for that is because f prime of x never changes from positive to negative along this interval. Everywhere we look, it never goes from above the x-axis to below it, which means there's never actually a maximum here. Now we need to start thinking about the second derivative. We need to think about points of inflection, where the function is concave up and where the function is concave down. The very, very, very important thing to remember about points of inflection is that something is only a point of inflection if the function changes from concave up to concave down at that point. So I always actually find it easier to figure out where's the function concave up and down instead first. So if I have the graph of f prime, need to pick a different color here. If I have the graph of f prime of x, then I know if the function is going to be concave up if the slope of f prime is positive. So when I take a look at the graph of f prime, I want to identify where is the slope of f prime positive. Well, that would be from -1 all the way until +1. And it would happen again from 3 all the way to 5. That means then that f of x is concave up not from, sorry. On the interval, let's see, -1 to 1 union with 3 to 5 because the slope of f prime is positive on these intervals. And again, we're looking at the slope of f prime. So since f prime is increasing along those intervals, the slope of f prime is positive, which means the second derivative is positive. That's how we know the function is concave up. Then let's see, what color haven't I used? We'll do red. The function is concave down anywhere that the slope of f prime of x is negative. When we take a look here, we notice that that is this interval. So from 1 to 3, f of x is concave down. On the interval from 1 to 3, because the slope of f prime is negative on this interval. Finally, we want to identify the points of inflection. We know that points of inflection happen when the second derivative changes sign. So when the function changes from concave up to concave down. Well, that happens at x equals 1, and it happens again at x equals 3. And we can see that when we look at our intervals of concave up and concave down. It's concave up from -1 to 1 when it changes to concave down. Then it's concave down all the way to 3, and that's when it changes back to concave up. So I'm going to write it in black only because that yellow is going to be hard to see. But f of x has points of inflection at x equals 1 and x equals 3 because, that was a really bad because there, sorry. The slope of f prime changes signs at these values. At x equals 1, the slope changes from positive to negative, and at x equals 3, the slope changes from negative to positive. And so that's what creates these points of inflection. So again, this was page 52 for your in your packet. So please make sure you are really comfortable with all of that. And if you are looking for a practice problem, you can do the one on page 55. That'll be a really, really good for review for you so that you can guarantee you are ready for your summative. Thank you so much for watching.